This next episode of Engine Masters is going to be kind of different because it's very personal to me. I needed to build this engine in order to fulfill my need to enter the 200-mile-an-hour club at El Mirage Dry Lake. And so I've got 347 cubic inches of small block, and it's got to make 1,000 horsepower. Welcome to Engine Masters, presented by AMSOIL, where this time it's going to be all about me and this engine and my quest to get in the 200-mile-an-hour club at El Mirage Dry Lake. Land speed racing, that's what this is all about. The car this is going in, you might even be familiar with if you are a fan of my other show, Roadkill. It's a second-gen Camaro that we have normally raced at the Bonneville Salt Flats. It's been as fast as 261 miles an hour. We've set a ton of records with that car, but naturally when I put it on Roadkill, it's the only time I've ever gone to a land speed racing meet and not set a record, and we haven't run the car since then, and I'm ready to make that right. This thing is gonna go in that car and get me in the 200-mile-an-hour club at El Mirage Dry Lake. You know, if it's the last thing I do. I've spent a lot of money making this happen, which is why this is gonna be a very personal episode. And instead of it being a real A/B test and technical analysis of something, this is more of a story about why I created kind of an unusual combination here, why I chose the parts that I chose, because land speed racing is weird. Think of this. In the last mile of Bonneville, 5-mile race, if I average 250 miles an hour, that is 14 seconds at wide open throttle, covering a mile with the engine hovering between about 7,200 and 7,600 RPM. That is abusive. And so we're gonna talk about how I built this thing to survive and how it's also built around the rules and around my own sort of personal and financial constraints in order to do what I needed to do. People have seen this thing on social media a lot, and they've asked a bunch of questions. I think I'm gonna be able to answer them all here in this episode. Now let's start to talk tech. I begin with the rule book. There's a lot of people who will build the car that they already have in their driveway and then figure out what class it meets. Instead, I look at the rule book, which also contains the records, and I figure out what class I feel I can set a record in. And then I build the car and the engine around that. Now in this case, the record that I'm looking at is at El Mirage Dry Lake, which is 1 1/3 miles on dirt, and I need to run exactly 201 miles an hour. And in that class, it is a C engine displacement category, which I'll explain to you in a minute, and it's gonna be supercharged, and it has to run on gasoline. So that begins to tell me the formula of what I'm gonna build. The next thing I know is sort of the power that it takes to make my car go fast enough. And I know that if I can make a solid 1,000 horsepower, that at Bonneville, I can run 250 to 260 miles an hour. Now that's a 5-mile track on hard-packed salt. At El Mirage Dry Lake, it's a lot harder and it's a lot shorter of a track. I need to run 200 miles an hour. Basically, my math says I need 1,000 horsepower. And so now we know that I need an engine that fits the C displacement category, which is 306 to 372 cubic inches. I know it needs to run on gasoline, I know it needs to be supercharged, and I know I need 1,000 horsepower. So now that puts me in a position of picking my exact combination. The displacement I chose for this small block Chevy is 347 cubic inches, and we'll get into the details of that, but let me tell you why I've picked that displacement. It's because it puts me right in the middle of that C category, but I can disable 1 cylinder and run on 7 cylinders, and then the engine becomes 304 cubic inches, and I can also run in the D engine displacement category. So that gives me an opportunity with one package to set 2 different records. And as I talk tech on this, you'll see that a lot of the choices are all about making the most of where I've spent my money here to make as many different records as I can. So we know that we'll be running this at 347 inches. We know it's supercharged. I will talk about the specific supercharger choices later on in the show. I know your next question is, how did I end up with 347 cubic inches? Well, I've got an aftermarket block here that has a big bore and a short stroke. The bore is 4 1/8 inches and the stroke is 3 1/4 inches. And so when you multiply that by 8 cylinders, that is 347 cubic inches. And the other reason why I chose that combination is the bigger bore, which is an 1/8 inch larger than a typical 350 small block Chevy, allows for more airflow. The shorter stroke, the 3.25 inch stroke, means less piston speed, which means more reliability at the high RPM that this thing is going to need to turn. So the displacement is not really the only unusual thing about how I've set this up. Here's an unusual thing. I've had a wrench sitting on the intake manifold the whole time. Perfect. The other thing that is kind of weird about this as a race engine is that the plan was not just build absolutely the most power I possibly can. Instead, it's about overbuilding the engine so that it can handle the 1,000 horsepower I need to make without really shooting higher than that. My goal is always overbuild and then make the thing make less power than it's really capable of so that everything is completely reliable. As a result, the bottom end is incredibly expensive and incredibly trick, and the top end is stuff that is not full race. It's more like high-end street-level stuff, and we'll get to that. The bottom end needs to be beefy because while guys are making 1,000 horsepower on LS engines with turbos all the time these days, I don't trust a junkyard short block at wide open throttle for more than a minute at more than 7,000 RPM making 1,000 horsepower. Because if parts fall out, they catch on fire. And at 250 miles an hour, that's a bad program. It takes a long time to stop. Parts can throw out of the block and go through a tire. Then you're barrel rolling the car. And so really it is a safety consideration. And it's about reliability. At Bonneville, you have to run 5 miles to get a record twice. You have to do it once in order to qualify and once to back it up. That is a lot of effort on the short block. And here's how I made sure that it was going to live. The block itself is an aftermarket unit called a Dart Little M. It's the beefiest small block Chevy aftermarket block you can get from Dart. Billet main caps, the whole shebang. The crank and rods I custom ordered from Crower. The thing that makes the crank trick is not just the super high quality, but also that it has a big block Chevy snout on it, which is larger diameter and stronger and cut with 2 keyways to survive the loads of the supercharger being driven off of it. And that means that it also has a special timing chain and a special front cover on it. By the way, this front cover is from Milodon. Everybody asks me about that. The other beef in the short block is in the very custom JE pistons that they made for me. These things are 2618 forgings. They have super precision ring grooves in them and 1.2 and 1.5 millimeter rings. The dome on them is custom made once again so that I can do something really freaky, which is change the volume of the combustion chamber in the heads to run low compression supercharged and high compression if I ever decide to go naturally aspirated. This is really weird. The dome is set up so that with this chamber on it, which is 78 cc's, it's 11 1/4 to 1 compression. If I put a 64 cc chamber on it, it is almost 14 to 1. So once again, I'm making choices that let me spend my money to use the same parts multiple ways for multiple records. And that piston itself is just beef. It's coated, it's trick. Next, let's get into the oiling system. Thing is, I really wish that I could have afforded a dry sump. It would have been the best thing for safety and reliability on this thing, but it's expensive and complicated. Instead, I have a custom-made aluminum fabricated pan from Billet Fabrications and a Titan pump. I had this in the car on a different engine, and the thing I'll need to do in the car is run vent lines from the valve covers down to these ports that I've got on the oil pan so that it balances the pressure between the crankcase and the top end so that all the oil doesn't gather up at the top. The other thing is, in the past, I've run screens in the lifter valley, and those are designed to keep chunks from getting down into the bottom end if you ever have a failure of any kind, but they also don't let the oil back down. And so we've made mods here to let all the oil get back in the pan so it doesn't pump up into the top while we're going down the track. Now let's talk about the top end, which is comparatively not that trick. And the reason I say that is it's not super high-end 12-degree race heads. It is not a sheet metal intake manifold. The camshaft is not like roller bearings or a large core diameter or special lifter angle or anything like that. They're off-the-shelf parts, stuff that you can buy. So while my bottom end is super expensive for reliability, my top end is just really good, high quality street stuff. It begins with Airflow Research 227 CNC cylinder heads. These are a regular, out-of-the-box 23-degree head that will work with regular pistons and everything. They do require a special valve train. It has a set of T&D shaft rockers on it, and that is only gonna help this thing with RPM and reliability. Now, the cylinder heads, I did have modified a little bit by Dugan's Racing Engines. I put in Inconel exhaust valves to survive supercharger heat for a long time, and those guys went through and perfected all of the specs on the head, including adding a wider exhaust margin, because a bigger margin on the exhaust valve can translate heat out of the valve and into the head easier, which is important when we're running wide open for so long. Speaking of valve train, the critical part of that was going to be getting a camshaft with a lobe profile that could handle high RPM endurance racing. So Brule and I went through and we kind of knew what duration we wanted. We kind of knew those basic specs, but we had to talk to Billy Godbold, who is the camshaft designer at Comp, and get him to give us sort of the secret special backdoor, profile that he knew was going to be able to handle even more RPM than what we're dealing with here. The cam lobe he picked is good for 8,700 RPM, and I hope to never actually get there, which means it's going to be perfectly safe below 8,000 RPM. Just for raw specs, it's a mechanical roller. The duration at 50 thousandths tappet lift is 245 on the intake, 256 on the exhaust. It's about 700 thousandths lift with a 1.6 rocker, and it's got a 112-degree lobe separation angle. But man, there's way more to it than that. That thing is like rocket science awesome. Now let's talk induction. Basically, not trick. This is an off-the-shelf Edelbrock Victor E single plane intake manifold. This is their unit that's designed specifically for multi-point fuel injection. That's why I got it. I couldn't find a manifold that I liked better than this one that came out of the box and had all of the holes in it for the injectors, and also that you could buy a set of rails for. And so I just did that for simplicity. Now the ports in this intake manifold come really small for home porting, and so we had the thing port matched to the AFR 227 head and tapered up the runner a little bit. It's not fully ported, it's just sort of basic work. And of course, I'm controlling the whole thing with Holley EFI. Normally on an engine at this level, somebody would use their Dominator kit. We're just using the middle of the road Holley HP EFI tuner. And I've also got Holley's elbow on here and their 105mm throttle body. And you'll see later in the show why this is pointed off towards seemingly the wrong side of the intake manifold. We've also got Holley's distributor in here, which is the dual sync, meaning it's got sensors in there that double as both a crank sensor and a cam sensor. And last thing, headers. This is only a 1 3/4 inch tube on these headers, which is really small for something making 1,000 horsepower. But the deal is, in the car, we have a set of 1 3/4 inch headers that fit really well and are tucked really tight to the floor. It's more important in land speed racing to get the car low for aerodynamics than it is to make that speck of extra horsepower that we might get with a larger diameter tube header. These dyno headers are actually going to be better than what we're running in the car. So there's the package thus far. We're gonna throw it on the dyno and run the thing naturally aspirated. And then later on in the show, I'll tell you all about the Pro Charger that's gonna be on here that's gonna take me where I need to be on that 1,000 horsepower. Let's go pour some AMS oil in this thing and get it running. The story about the oil for this engine is actually more interesting than most. So I called Crowler to custom order my crank and rods for this thing, and they knew what I was doing with the supercharger and with the endurance racing and all of that. They wanted to know what oil. It's like AMS oil, Dominator, which is their racing oil. And Crowler really pointed me in the direction of the 1550 weight, which is heavier viscosity than you would normally use in a racing engine, but it's what they wanted to see for the duration that I'm gonna be running this thing at wide open throttle, and also for the fact that it's got supercharger loading on it. So of course, this thing is gonna be running on a full load of 8 quarts in the pan, the Dominator 1550. This is it. We're gonna show you how this thing runs to 8,000 RPM naturally aspirated.
Nervous?
Yes. so we just made 432 pound-feet of torque at 5,400 RPM, and the horsepower peak was 534 up at 6,900. But in this case, those power peaks weren't really the point of what we're doing here. This is more like a checkup, a look-see. And that's why, even though it made peak power all the way down at 6,900, we ran it to 8,000, because I suspect when we put the supercharger on it, it's gonna push the power peak higher in the RPM curve, and I just wanna make sure it's stable to there.
Yeah, with an ascending boost curve, it's gonna kind of stretch it out some. So I think it's probably gonna be, I don't know, mid-7s, 78, 79, something like that.
What else does this tell you? It tells me, I think it's actually pretty healthy. I mean, we look at 534 horsepower as not that big of a deal these days, but if you look at the specific output of this thing, so it's making 1.224 pound-feet of torque per cubic inch. Can we look at the oil pressure curve on it? Yeah, it never dives, although it goes to 104 pounds, and with that pressure is probably enough volume to be pushing oil upstairs, and I'm worried about that too. I don't have a dry sump on it, wish it did. Anything else you guys are seeing before we move on to supercharger that we need to look at, consider, talk about?
Too, I didn't see a lot of blow-by or smoke out of the headers at high RPM, which a lot of times you get ring flutter and different things that'll unseat the ring or seal the cylinder. This thing was pretty darn clean.
It has a 1.3, 1.5 ring pack in it, which seems thin, especially for the supercharger and anything. But you know, the new thought is that, what?
Oh no, I'm just smiling because you start seeing that a lot more, and guys go, how narrow on a blower motor?
Yeah, but what it is it's ring to wall conformability that maintains the seal. You know, we used to think that you needed a 5/64 ring or a 16th inch, you know, thick piston ring to transfer heat and to maintain tension and to seal, but the trend is just towards thinner and thinner. And the custom pistons, like, there is no up and down wobble at all on the piston ring.
How far
is
down?
In the groove. And they're custom made so that the ring is further down the piston than it normally would be, so that it can endure the heat for the longer distance. Okay, so I think we know what we need to know, naturally aspirated. So we're gonna move on to hanging the supercharger on this thing and working it up from there. So there you go, 535 horsepower from 347 cubic inches. And you know what? We ran this thing on a carburetor in earlier testing and made almost 550 with it. The thing that is of value to you about that is a whole bunch of fans have asked us to show a big bore short stroke, high RPM, naturally aspirated combo. And basically, there you go. Now, a reason why it's important for me to make as much naturally aspirated horsepower as I affordably and practically can is that the more NA power that you make, the more power you're gonna make blown with a lower boost number, and that lower boost number builds less heat and tends to be more reliable. So I'm happy with that 530, 540 kind of horsepower number. Now, the supercharger that I'm gonna use is right there. The ProCharger F1A94. I've become a ProCharger guy. Go back a couple episodes on Engine Masters and you'll see that we put one of these things with a rib drive belt, a serpentine belt, on a stock 350 small block Chevy and made like 765 horsepower. This is that race unit. You can buy it with a cog drive directly from ProCharger. Now, a lot of people have asked me, why aren't you using a turbo? Turbos are the latest and greatest thing. You can make so much more power. And I can't deny it. I could make more power with a turbocharger on this thing than I can with this particular ProCharger. But there are reasons why I didn't want to run a turbo. Let's look into that a little bit. First of all, the ProCharger goes on and off the cylinder head with 3 bolts. 3 bolts in a belt, and I can remove or install this supercharger, which is important for a couple reasons. Serviceability, which is a minor reason. The bigger reason is, once again, changing racing classes from blown to unblown. The turbo kit is gonna completely involve the whole exhaust system. It's not gonna be easy to just get on and off the car, whereas this is. So that's really important to me. Also, with the turbocharger, it has the potential to have a lot of brute low-end torque. I don't really want to have to manage that, even with my EFI program. I'm trying to go 200 miles an hour on a dirt road. Traction and acceleration are a big problem. This centrifugal supercharger has a rising boost curve that's gonna have a much more controllable power gain so that I can put the power to the ground so I can get down the track. And that's a very real thing. The other thing about the turbocharger, at the kind of 20 PSI range, 1,000 horsepower range that we're looking at here, you've seen even on the dyno how exhaust parts will glow red hot. That is a problem in a land speed car going down the track because there's no airflow through the engine compartment because the grill is blocked for aerodynamics. I don't want glowing red hot metal parts in my engine compartment, especially because if I had a gas or a fuel leak and it touches that stuff, whoof, instant fire. That can happen anytime you're making this kind of power, but I believe personally it's a much greater risk with the turbocharger, so I am happy with the ProCharger. And we're gonna find out why right now, because we're gonna go bolt this thing up to the engine. It's gonna be super easy.
All right. Now for some real power. What I've got here is a ProCharger F1A94, and this unit's good for right around 12 or 1300 horsepower. We're looking to make around 1,000 with the small block Chevy. And it mounts right here. The centrifugal supercharger is much like a turbo, but instead of using the exhaust to drive it, it's driven by the crankshaft. Now here we've upgraded the drive from a typical serpentine to a cog belt, and that eliminates any possibility of slip. Now the crankshaft at max speed is going to be at 8,000 RPM at this engine. You have a drive ratio between the drive gear and the driven gear, but also inside the housing here, we have a step-up ratio. This one is 5.4 to 1. In other words, for every turn here, the impeller is going to be turning 5.4 times faster, up to a maximum speed, as indicated on the data plate here, of 74,000 RPM. We're going to get this hooked up to an intercooler and then into the air intake, into the engine. We'll see how much boost it puts out, and we'll evaluate the whole system on the dyno. Hey, Brule, what's going on here, man? Is Freiberger in his trailer? I mean, it's his motor. We're doing all the heavy lifting here.
Makeup.
Makeup?
Yeah.
Oh, man, he's got to look his best.
He's trying to put that red helmet back on that he had when he was 15.
Oh, yeah. We have the tune-up right on the engine. We made sure everything was mechanically okay, but the air is not quite as good. It's warmer, plus there's more humidity or moisture in the air, so we're gonna do a pulley change to make the blower spin a little bit faster to compensate, and then we should be making the power that we're making with this engine in our original testing, the baseline.
As if by magic, the ProCharger shows up on the engine. It's actually a super easy installation. 3 bolts hold this bracket onto the front of the cylinder head, and then we just have discharge tubing here going through our massive, I think 2,200 horsepower capable air-to-water intercooler, and Pork Chop's working on plumbing that. This is in, this is out, through the blow-off valve that he's about to install, and through our Holley 105mm throttle body, through the elbow, into our single-plane Edelbrock intake. Okay, we got the blower on there now, and off camera we've run this thing a few times and sort of struggled with the tune and some things a little bit, and it's down on power. I guess you add up the fact that it's hotter, it's more humid.
80% humidity.
And the boost is down 0.4 to 0.5 PSI.
At least.
And we know that the air temp in the intake manifold is 20 to 30 degrees hotter.
Yeah.
So I hope, bench racing wise, that all of that adds up to about the 80 horsepower loss that we were seeing versus what we were doing before. So this is gonna be our pull with our new smaller blower pulley and just a mechanical checkup, making sure that that engine's happy. This should be good for 1,000 plus horsepower.
Pretty good.
Was it good?
Yeah, I saw like 1075.
I was kind of pegged left eye on the air fuel meter and right eye on the motor.
I had your trust on the AFR. I was looking at oil pressure and fuel pressure.
Perfect. So yeah, that was good that time. It was a good change.
Yeah.
Yeah, and it's still on its way up, 7,600 RPM, 1,070 horsepower, and 760 pound-feet of torque.
Yep. When we started out, we had a bit different fuel pressure that we had to spend a little time tuning around. So you need your own regulator on your rail.
I'll bring my
so that
pump,
doesn't
too.
happen. Yeah.
You can't mess around because the thing's going to be at wide open throttle like
Forever.
Forever.
These things, you know, a 9-second pull seems like a long time. It's not anywhere close to what you're going to do to it.
So I guess The real lesson here is that when you come to the dyno with something like this and you really have a specific plan on what you're going to do with the engine, it's not just a street drive around, do burnouts, you know, make 1,000 horsepower with a junkyard motor.
I mean, we learned a lot. And,
it's a 347 cubic inch engine that makes 1,070 horsepower. It's not bad.
Yeah.
Exactly. You know what? Thank you always for your help with my actual racing program.
Yeah, it's
and
cool.
I'll expect you to be there with me at the garage.
Oh, you know it.
Let's go wrap this thing up. It's a really different game when you've got your own money riding on the dyno like that.
I only want to get one thing out of this whole engine.
What's that?
For you to be happy with it.
Oh, well, I'll get there. You know, I feel like this has definitely been a step in the process. There's nothing I'm unhappy with.
Right.
It's just I want to go to a further level of tune and confidence, and I want to get more comfortable with the Holley EFI myself so that when I'm racing the thing, I can deal with it in the car.
Well, yeah, if you're racing this, you've got to know every aspect of the engine, how it works, and all the intricacies of it for sure.
You have to, because that situation is way riskier for this investment than it is running it on the dyno by a lot. But, you know, 1,000 plus horsepower, 347 cubic inches, and I think, you know, safe. Definitely nowhere near pushing the limits of anything here, except for we're at the RPM capability of the supercharger.
I mean, a lot of times we're chasing a number, or we're just slamming the thing on the dyno, we're shooting it. We're doing a good job, but we're not taking it down Bonneville for like 30 seconds at wide open
This is
throttle.
a different game. And I guess last thing, wrapping it up, what do you think my odds are?
I think it's 100%.
Think we're looking pretty good?
Yeah.
I
We'll
think so
do
too.
it.
I hope that when we actually run this thing at El Mirage and hopefully get in the 200 mile an hour club, I'm working on doing a documentary right here on Motor Trend. Maybe we'll get that done. But regardless, follow us on social media because you'll get to see what goes on with this engine in the future. So on Instagram and Facebook, we are at Engine Masters, and I'm at David Freiberger. He's at Steve Dulcich. Brule is at Dyno Brule. And of course, you can also follow our sponsor at Amsoil Inc. We appreciate all of their help, and also the guys at Holley who helped make this happen. And on this particular episode, I really appreciate the support that I got from Airflow Research and Comp Cams as well. So that's it for this Engine Masters presented by Amsoil.